in there that is no more than 20 characters long. If you try and put a 21 character string in there, it's going to throw an exception and complain and so forth. And whereas Tcl doesn't really have types. Everything pretends to be a string. Of course, we know underneath the covers that it's storing things in efficient binary formats, but to the programmer, it looks like everything is a string. It's very flexible. We all know how a wonderful thing that is. But here we have this old, rigidly typed view and this modern, untyped view, and there's this vast chasm that sort of separates these two models. Here there be dragons, and here is where SQLite lives. And so there's a little bit of an impedance mismatch that SQLite has to overcome. And it does this by this idea of, instead of being completely typeless like Tcl is, it does have a concept of types, but it's very flexible in its typing. So, for example, in our thing before, we've got this field called user ID, which is of type integer, and it wants to hold an integer. And so if you take a string, put it into that field, it will try to convert the string into an integer. If the string looks like an integer, it can be converted without loss of information. It will do that. If the string is just like, say, hello or something like that, which can't reasonably be converted to an integer, it stores it as a string. Or if you insert a blob or a GIF or an MP3 file, it'll store whatever it is you put in there. It tries to convert to an integer, but if it can't, it leaves it as it is. Same with varchar, it tries to convert it to a string. It's usually much more successful at that because every integer can be converted into a string, right? But if you take a blob and put it in there, it'll leave it as a blob. So we've got there's additional information down there. This is kind of a complex subject. It confuses a lot of people. In the interest of time, I'm going to move on. We can talk about it more later. Now, in SQL, you have an insert statement that inserts data into a table. And here I'm just inserting a record into the user table that I created. And that creates these 3 entries into the table that are stored on disk persistently like that. Now, of course, that information is not useful to you unless you can actually query it. So you use the select statement to find out what information is in your database. And here we're selecting all the records out of the user table. We're selecting the user, the first name and the last name. As you can see, it returns this information as a simple Tcl list with one field per element of the list. And so I'll insert another record, which is my wife's name. And then we query it again, and now we see that it just doubled the length of the list. It's not putting individual rows, it's not demarcating individual rows in the result, it's just giving you one element per unit of the list. Now, the really interesting thing that SQLite sort of pioneered, and to some extent I think TDBC has copied, is the ability to, when you do the query, have a little procedure that runs for each row in the result set. And while you're running this procedure, the values that you're pulling out of that particular row are stored in local variables. So you ever got a little procedure that does a couple of puts calls, and it's spitting out the value of the variables for each row in the result set. And it loops. This is a very powerful concept. SQLite, as you know, or may be aware, has been ported and works on just about every programming language there is. It's a standard part of Python, PHP, it's in every web browser and every cell phone. It's used all over. For all of the language bindings for SQLite, none of them have this power. Only in Tcl can you do interesting things like this. And since this is a kind of a procedure, it's kind of like a loop. Things like break and continue work just like it were a for loop. It all works exactly as you would expect. None of the other languages that bind against SQLite will let you do this sort of thing. You can also, here's an interesting trick, you do the select statement and your procedure is going to be just a simple break command, which causes the whole thing to stop. And it just left the value of the first row in those variables, which you can then access separately. So, we're going to add another column to our table. And this is going to be for a picture of the person, I suppose. And this is really, really interesting. So what I'm going to do is I open up a file which contains some big binary thing, a JPEG image, which might be 3 megabytes in size. I don't know how big it is. And I read all of that content into a Tcl variable called drh_photo. And then I close it. So it's all in this Tcl variable. And then I run db eval, and I'm going to update my database to insert the content that I just read in off the disk into that field. Now, take note that the SQL that I'm inserting here is in curly braces. That means that the variable name that is inside those curly braces is not being expanded by the Tcl interpreter. it's passed directly down into SQLite. SQLite knows this. It sees that there's a $sign, DRH photo there. It says, aha, he wants me to insert the content of that variable. And so it goes out and it gets the content out of that variable and does the insertion directly. This avoids unnecessary copying of a possibly very large JPEG or MP3 file or whatever you want. It also completely eliminates the possibility of an SQL injection attack, if you're familiar with what that is. This is a very powerful concept. It is only available in Tcl. Of all the other languages that bind against SQLite, you can only do this in Tcl. I begged and pleaded the PHP people, the Python people, do something like this. No, we're not going to do that. We don't like that. So now, one problem here is that Tcl has this dual representation, and so that object we read in might have had both a byte array representation and a string representation. And which one does it insert? If it has only the byte array representation, it inserts as a blob, but if there's a string representation, it'll go in as a string. Now, in this particular case, when you do a read of something that is open binary, it's going in as byte array only. There's no string representation. But if you've done something unnatural to this variable beforehand, it might have a string representation there, and that can confuse things. And so I allow you to put an @ sign in place of the $sign, and that forces it to use the byte array representation. This is an example of that dragon I was talking about earlier. This doesn't ever come up really in practice, but you should be aware that this potentially can happen. Another really cool thing is the ability to manage transactions really well in Tcl. Here, you might have a transaction that involves multiple statements in SQL or in Tcl. And so the DB transaction method is followed by a script, and it runs the script. And at any point in the script, there's an error. A Tcl exception is thrown, or you actually specifically call error, the error command, and throw an exception. And so it comes out of the script as an error. It will automatically roll back the transaction. But if the script succeeds, it will automatically commit. You wouldn't, this seems kind of trivial and simple, but if you've ever tried to write a script that correctly handles all the error conditions, this makes things so much easier. You really want to do this sort of thing. Tcl gives you the ability to define new user-defined functions directly in Tcl. So here I'm creating a Tcl procedure called square root function, and it takes the square root of its argument. And then on the third line down, I'm saying, all right, whenever we use the SQL function sqrt, call this Tcl procedure. And then I'm doing a select, and we can see, in fact, it does compute the square root, which is, all that useful for doing numerical things. But, it doesn't have to be just a numerical computation. In that Tcl procedure, you can do all kinds of really interesting things. So, for example, you could have a Tcl procedure that, say, gave you a GUI editor. And you could, so it pops up a graphical editor of some text string that is its argument, lets you edit it, press enter, or press a done button, and then it'll return the edited copy of that text. And then you could do something like this, where you can see the bottom line up here. We're doing an update, some table, set message equal to edit message. And what it'll do is it'll pop up this graphical editor, lets you edit the text, and then when you press OK, it will return its value, and the update statement will complete and modify the result. As far as I know, there's no other system in the world that will allow you to do this sort of thing. You can't really do this with a client-server database engine because it's running in a separate process. This only works because SQLite is local to the process that you're running here. There's lots of cool tools that you can grab to help make your SQLite Tcl-enabled script work better. And here's a URL where you can go get them, and you can get that off the PDF. Like there's this cool console that you can cause to pop up that lets you interactively type in raw SQL to debug your application. And that's useful if you've got an application to have a little debug menu, and it'll pop up and give you the option to bring this up. There's also another little graphical database editor that you can just download, drop the file in place, and it's just going to run. There's lots of little tools like this. I can't really go into the details right now, just for one at a time. But maybe you're, in spite of all of this, maybe you're still thinking that you're unconvinced that SQLite really is a Tcl extension. Well, let me give you some more evidence. As of last week, This is on the tarball of SQLite that you download. 73 and a fraction percent is written in pure Tcl. About 3/4 of SQLite is in pure Tcl. Now the part that comes in your Firefox web browser, that's the green part, that's written in C. But in the tarball that you download, about 75% of that tarball is pure Tcl. Tcl must be installed on your development system in order to compile SQLite, bottom line. Tcl must be on your system in order to test SQLite. It has to be Tcl 8.5, by the way. 8.4 won't work anymore. All of the SQLite documentation is written as Tcl scripts. Well, but a lot of the arguments in Tcl scripts are a bunch of HTML, but still, it's Tcl scripts that run and then generate all the pages that are on the website. I don't know if you've been watching lately. We've got these really cool syntax diagrams that we do for Tcl now that are, I think, are much easier to understand than BNF. They are all generated using Tcl2k, using a specification like I've shown here at the top of the page. The specification at the top of the page is what generated the syntax diagram at the bottom. And the way this works is there's some Tcl code that runs, reads that specification, draws an image on a canvas, runs the PostScript method on the canvas to generate PostScript, and then it runs exec to use convert to render the PostScript at the resolution I want and give me a GIF. So all of those things are done purely with Tcl2k. Bottom line, SQLite could not exist in any form without Tcl. It's a Tcl extension. Now, so SQLite is a Tcl extension, but I don't want to deceive you into thinking that SQLite is a general purpose SQL database just like all the others. All these other guys, they're very powerful, they're great. SQLite is very different from those in a number of important ways. One is that SQLite is zero administration. By that I mean there's nothing really that you need to do to administer it. Most big database engines come with a database administrator. In fact, there's a job title, Oracle Database Administrator. Are there any Oracle Database Administrators here in the room? But they're pretty common, and you probably know one at your company.
My sister is an Oracle Database
There you go. Will's sister is an Oracle Database Administrator. I mean, it's a full-time job, just keeping Oracle running.
She thinks she's a programmer.
Yeah. So the thing is, SQLite is used on things like cell phones and stuff, and you just don't really want to have a database administrator to go with your cell phone. It's expensive, and plus most database administrators, Will's sister accepted, of course, are not nearly as good looking as this one. So another way to think about SQLite is by analogy. Here's a picture of a recording studio. This is a full-featured recording studio. It's very complicated, lots of cables, equipment. It takes a lot of specialized knowledge to use this. This is the sort of thing that you would want to have at your disposal in order to make a CD of the next great boy band or something. This is what you need. This is a personal music listening device. So I assert to you that a traditional client-server database engine is to SQLite as this big recording studio is to an iPod. I mean, you can do a whole lot more with Oracle than you can with SQLite, but sometimes you just want to listen to a tune. You don't want to have to mess with all these other cables. That's very important. Yes, Will, it's your question.
Should we draw the obvious conclusion from this slide?
What is that?
That SQLite is running on the iPod?
It is actually, but that's not why I made this slide. So, our kind of model is SQLite is not intended to compete with Oracle. SQLite is intended to compete with fopen. Okay? It's a very different concept. SQLite is a very portable file format. With other database engines, every time you upgrade to the next point release, you have to dump the database and reinstall it, and you can't move the database files from one machine to another. SQLite's file format is stable and it's portable. It's backwards compatible all the way to version 3.0.0. You can move it between different platforms, big Indian, little Indian, 64-bit, 32-bit, same file format all the way around. So, and it's also a single file on disk. So we've got a zero administration, portable file format. This makes SQLite great for an application file format. What do I mean by that? You're making a new application, typically you have a little menu bar, file open. What does that do usually? Well, normally you do an open and you start parsing a bunch of XML, or maybe it's some Tcl set statements to load in all your data. It's a bunch of stuff. And it's a big mess, and then you have to do the file save. It's going to write it back out, and it's a big hassle. Why not just open up an SQLite database and make that your file format? You don't have to give it any, you can put your own proprietary extension on the end. It doesn't need to be SQLite or anything, or DB or anything like that. Just make it your database file format. There's a lot of advantages to that. You don't have to write any code to parse and generate your file. You get atomic updates for free. Atomic meaning that if you lose power while you're in the middle of writing, it's automatically going to revert back. It's not going to damage your file. You get fast built-in searching, access. You can read your file using third-party tools. There's this huge number of advantages to doing things this way. Another advantage of SQLite, very small footprint. As of last week, with the Tcl interface and the whole bit compiled, it's less than 300 kilobytes. So, and if I compile with -03, which does lots of loop unrolling and function inlining, and I throw in the full text search interface, and I throw in the Artree search engine, it's still less than a megabyte. It's very small.
That won't run on DOS 3.
Okay, well, whatever. The SQLite is a single source file. The one you're interested in is Tcl SQLite 3.c. One source file. It's a big source file, 68,000 lines of code, almost 4 megabytes of code. It really stresses a lot of text editors. If you're using Microsoft development tools, do not try and debug this because they get really upset if the files are longer than 65, 536 lines. But still, it's just one file. And what that means is that you can drop this file, this SQLite 3 file, down in the middle of your C program, just like any other file, and then compile it along with all the other C modules, and suddenly you've got a full-blown SQL database engine right in the middle of your file. This is a snapshot of fossils, of the fossil source tree. And Fossil uses SQLite, so I just drop these files right in there, and I've got the complete database engine right there. I don't have to have a separate subdirectory just for those files or anything like that. If you look at the T distribution for SQLite, and you look at the generic folder where people normally have a big stack of C files to implement their extension, there's exactly one file, Tcl SQLite 3.c. That's all you need to have Tcl in your program. In fact, if you wanted to compile it without using all this stuff, compiling SQLite is really, really simple. You just have that one file, Tcl SQLite 3.c, and you just give it to GCC. And it does all the right stuff. There's nothing else there. There's no configure script to run. There's no options to select. There's no complication. You just compile it, and this is actually like screen capture, folks. And you compile it with that one little line, run Tcl shell, load it, and it starts running. Just like that. It's very simple to install and operate. Other features of SQLite. You can have gigabyte-sized blobs and strings, and that actually works. Some folks at Adobe did some research, and they found that for storing image thumbnails, as long as the image thumbnail was less than about 50 kilobytes in size, it's faster to store it as a blob in an SQLite database than it is to open it as a separate file and just write it out to the disk. And that's true even though SQLite is atomic and gives you rollback and all the transactional. We get terabyte-sized databases, 100% branch test coverage is very reliable. We've got nested transactions, full-text search, Artree search for geospatial type problems. The attach command is an extension to SQL that allows you to have multiple database files open at the same time and to do joins across multiple databases as if they were a single database. It's robust against power failures, memory failures, I/O errors. You've got referential integrity checking, which is brand new, and that includes deferred constraint checking, cascading deletes, the whole bit. And all of these features have really made SQLite very popular with a lot of companies. And we've enjoyed a lot of success. SQLite is the application file format for Adobe Photoshop Lightroom. SQLite is used in Adobe Acrobat Reader. I don't know why or how, but it is. It's in Firefox. It's used there. It's also in Safari. It's in your Nokia cell phone if you happen to have a Nokia cell phone. It's in your Google Android phone for those of you who have the Google Android phone. It's in your iPhone for those of you who have the iPhone. It's in an iPod and an iTunes. It's there. It's in all kinds of stuff. It's in a BlackBerry. It's in the new Palm WebOS appliance thingy. It's in Skype. So if you use Skype, you're using SQLite. It's in the Sony PlayStation. And lots of little gadgets like this. It's used all over. I'm regularly finding some new use of SQLite. It's in the public domain, and so people don't have to tell me that they're using it, and oftentimes they don't. It's also in a lot of open source software. It's in Tcl if you get active Tcl, but it doesn't really come with Tcl by default, which I'll comment on in just a second. But it comes by default with Python and PHP. It's just there. Nothing to add. It's just there. It's in Subversion, Rails, Fossil, Monotone, Track, Yum. I don't even know how to say the name of that thing with the music player. I won't try. Maybe you've looked at SQLite in the past and said, well, it's missing some features. Look again. Since I last spoke on SQLite at a Tcl conference, we're 25% faster. We have check constraints now. We have save points and nested transactions so that you can nest your transactions and roll back partially to one of the nested levels. The query planner is much, much enhanced. We can it now uses indices even if you have OR terms in the where clause, and it does a much better job of reordering joins to get an optimal query plan. In fact, we're getting reports there's a lot of people that are substituting SQLite for large-scale database engines, Informix, Oracle, and they're saying that that they're not having any complaints. Our query plans are just as good as those generated by the enterprise-scale database engines. We've got recursive triggers, foreign key constraints, as I said, including both immediate and deferred constraints, and cascading deletes, cascading updates, all that sort of thing. And all the source code is managed by Fossil, so it's very easy for you to make your own private copy and your own forks and branches if that's what you want to do. So, some closing thoughts. Why shouldn't you be using SQLite in your application instead of just opening and doing your own file format? 2, why isn't Tcl SQLite 3.c just part in the core, and why isn't it just there so that it's always there with us and we always have it available? Is that a question, Gerald?
Yes. Has anyone tipped that that be so?
Well, I felt bad about doing that when I was actually in the core team. Now that I'm not on the core team, I guess I could do that, right?
Right.
Okay, that would make sense.
And you're having trouble with the implementation part. So.
Yeah. And the funny, I talked about this amalgamation, having the whole thing as one big file. I found it very, very useful. Remember how I put SQLite into Fossil by just dropping a single file in my repository? I really, really, really wanted to use an official Tcl in Fossil as well. But I could not bear to put the whole source tree in. I wanted an amalgamation of Tcl. It didn't even have to be the latest. It didn't have to have all the features, just the core basic Tcl. And so it turns out that one of my helpers on SQLite, Dan Kennedy, had written sort of a little tiny Tcl clone that we had planned to use for something else, and I dropped that in there instead. But I'd still like to strip that out and replace it with an official Tcl amalgamation, if that were possible. Yes, Steve?
Could that just be a post-processing of the source?
Well, that's in fact exactly what the amalgamation is. In truth, in our source tree, SQLite is 80-odd source files. And then the amalgamation is actually a build product. There is a Tcl script that runs, it reads these individual source files and pulls them together in just the right order, making appropriate adjustments to sharp include statements and so forth, to put it all together into one big source file. So it's really a build product that's done by a Tcl script. And the guy who came up with the idea of the amalgamation is Shane Harrelson, and he also is working with us on SQLite now too. So, and I will leave you with this one final image of, Tcl, SQLite really does complement Tcl really well, and I encourage you to use it in your applications. Are there any questions? How much time did I actually end up with, Gerald?
You overran by 4 minutes.
I overran by 4 minutes.
So you can go off more if you want.
No, I'll answer questions if there are any. Everybody wants to break. Oh, question from Jeff.
So getting back to, what was it, Arden, whoever asked me earlier whether zlib was a good thing to put in the core. Really, I should be looking for security issues in SQLite, and then I can hack anything.
Well, not really, because you think about it, I get a lot of pushback on this. Oh, we can't statically link SQLite because our security policy is such that we have to dynamically link everything. Fedora Core says that. They will not allow you to statically link a library. And that makes sense for zlib, for libjpeg, for these sorts of things, where you're taking raw data from untrusted sources and handing it directly to the library. You're not really doing that with SQLite. If you're taking raw SQL and handing it to SQLite, you already have serious security problems in your code. Okay, you see what I'm saying? With SQLite, there should be some pre-filtering and some processing to catch the exploits before you ever get to the SQLite library. Not so much with zlib, where you're taking the raw data and you're having it decompressed or interpreted directly. So the security implications are different.
By the same token, SQLite databases are files. And
Yes, they are.
So you can conceive of attacks at that level.
You can, and so that would be a possibility. On the other hand, not many applications take an entire database all from an untrusted source. Typically, an application that's facing a potential attack, the information it's taking in from the attacker is not a complete database file, which it then reads. Now, if you did something like that, yes, then SQLite would be subject to the same security problems that zlib would be. But that would be a very unusual use. Other questions? Thank you for your question.
How do you respond to people who ask about things like scaling, replication, backup, live, while the databases?
We do have a live backup capability. It's accessible from Tickle. It's just another method on the structure. And there's a bunch of, I showed you, I think, 3 methods, maybe 2 methods. Yeah, eval and transaction. There's 24, okay, and one of them is backup. And it will do a live backup of the database while it's in use. Replication, well, you can do a live backup.
There's a script that does that.
It's scripted. You can script it. I mean, remember, we're not trying to replace the database server. We're trying to replace fopen. And I don't think fopen does replication either, does it? Not the version. Yeah, somewhat. Other questions? Thank you for your attention.
We'll take a break till 4 p.m.
Yeah.